Last time we did product rule. This time we did quotient rule. Product rule was about multiplying. What do you think quotient rule is about? Oh, thank God. Just kidding. I didn't doubt you for a second. All right, so let's find the equation of the tangent line. Let's do some bell work. Of g of x when g of x is this thing here at pi. Okay, so first thing I need to do then is I'm going to need pot and sop. My pot is going to be pi. What's the sign of pi? So anything times 0 is 0. Then my sot, which means I need to find the derivative first, right? And since these are two things multiplied together, what does that mean? No, I'm sorry, I couldn't understand you. Okay, so
you have to do f prime times g, then f times
all right,
g prime.
good. Derivative of the first one, 1 over 2 root x. It's a little hard to read.
Why is that what pi 0?
Because what is sine of pi? 0, and anything times 0 is 0. No. Root x times the derivative of sine, which is cosine. All right, good. Now we got to find g prime of pi. Well, what's sine of pi again? 0. What's 0 divided by anything? Perfect. Square root of pi. What's cosine of pi?
-1.
Nice. So g prime of pi is negative square root pi. You hate this. All right. So then I can write the equation of my tangent line. Y minus 0 equals negative root pi times x minus pi. Amazing. Are we good? Amazing. All right, let's do it for real now. Let's do the quotient rule. All right, so we're going to rewrite this function as a polynomial-like function, and then we're going to prove that my quotient rule works, just like we did yesterday in product rule.
Hey, Miss, I have a question.
Yeah.
What is the most advanced math you can teach?
Me? Differential equations?
That is busy.
No, it's way beyond that. Well, I mean, thing is, like, I've done differential equations, linear algebra, calculus with stats. I don't like
Like
that
in
one.
a college. You can
But yeah, yeah, like
when you go to a college.
I have a couple students right now in university. Yeah. Yes. This class, or like I love teaching physics, kinematics. I love that. I like pretty much everything about physics except I don't like light. I don't like it. Just don't like it. It's annoying. Would you agree? Do you dislike light?
What?
Light?
No, I dislike electricity.
I love electricity.
Circuits
Get
is
out.
the best. Mechanics is the best.
Fair enough. All right. Anyway, let's get back on track. So the first thing I'm going to do is rewrite this. And I'm basically going to rewrite it without the common denominator, right? We've done this before where we're going to like split this into 3 separate fractions. No, we've done it before. So this would be 2x minus 3 plus 2x to the negative 2.
I need to wait.
Wait on what? Look, 2x cubed over x squared is 2x. Negative 3x squared over x squared is negative 3. And 2 over x squared is 2x to the negative 2. Right? We just split apart the common denominator. We've done this before. Okay? Excellent. Now that's real easy to take the derivative. What?
Can you explain? I understand. Like, why did you do it all at once?
But I did explain.
Yes.
Okay. And then there's the derivative. 2 minus 4x to the negative 3. Or I guess if you wanted like 2 minus 4 over x cubed. Same difference, right? We could say like, or 2 minus 4 over x cubed. Same difference. Okay? All right. So, just like Leibniz was the first to publish the proof for the product rule, Newton was the first to publish the proof for quotient rule. Using the limit definition of the derivative, let's write this rule together in the box below. So, if h of x is equal to f of x over g of x, then h prime of x is equal to f prime g minus f g prime all over g squared. Or, as I prefer to call it, low d high minus high d low. It's like a song.
Oh my gosh.
So let's take that song apart for a second.
But can you
Low.
wait so I can write?
Yeah, we'll wait.
Thank you.
Get used to that song.
It's
not really a song. It's more like one line from a song. But get used to it. What?
Why did you put the parentheses below?
Because I'm squaring the whole thing, not just x. All right, are we done?
No. Low D high.
Sir, maybe sir, we saw this last year.
No, this is just g. What?
We saw this last year.
Yeah, you did. You have this and one. Did we learn chain rule last year?
We did.
It's I learned all the rules.
Well, like the first.
But did you do chain rule? I don't think so.
Yes.
Yeah.
We did? Okay, so you've got like one more lesson. And then it'll be different,
Sir,
I think.
sir, in which cases can we use both product of powers? Many would be the correct answer.
All right, guys. I need this question to stop being asked. So I'm going to address it one last time, and after this, I'm going to laugh at you. This is not your fault. You're the fourth person today, okay? So, guys, the way you know how to use these rules is literally in the name. If it has a power, i.e. exponent, you use power rule. If it has two variables multiplied together, product rule. If it has two variables divided, quotient rule.
Again.
If it has a power on the exponent, you use power rule. If it has two things multiplied together, product rule. Two things divided, quotient rule. If you have a combination of like multiplication and division, multiplication and powers, whatever, you use both.
So we do it in power.
Not necessarily.
Right, but be careful. I've seen a lot of people differentiate e to the x by subtracting 1 from the x.
Well, that's their fault. They don't know what that one is yet. So, anyways, okay. So let's go through this. Ready? Low d high minus high d low. Low g. Look. Actually, you know what? Let's do it this way. Low d high.
Hey, Mr. I have some very good tricks.
Okay. Minus high. Which would be this one as well.
Put a different color.
I did. D low. All over low squared. Right? Are you two okay? Okay. Just making sure. All right. So, low D high minus high D low. If you don't remember how to do quotient rule, just remember high D low or low D high minus high D low. Over low squared. Anyway. All right. Let's actually apply this. And we're going to prove that we get the same thing. Ready? Now, guys, remember, when we do the proof ones, they're always more work. But then later we're going to be like, haha, now you have to use it.
But so that only covers the upper part.
Well, yeah, I said over low squared. Low D high minus high D low over low squared.
You said
Thanks,
how
man.
I
Over low squared. Better? Make you feel better?
it confuses me that the first thing in the song is not the first thing.
Yeah, that's what I was thinking too. Should be behind.
Because that's easy to say. D lie ho. D high low.
You're trying to make it complicated.
D high low. It just sounds bad. It just sounds bad, guys. All right, so f prime of x is going to be low x squared. D high, 6x squared minus 6x
Yeah, I don't.
minus high D low. I don't know. You guys asked me to go slow. It's awkward. Over low squared.
Wait, Brad, how do you draw the lines?
Shift.
Really?
Yeah, see?
Wait, this whole time I've been.
Or are you trying to do it like this, like a chump?
Yes! And it took like 30 tries.
Shift. All right.
Sir, I don't understand how you got what is f of x and g of x from the function.
Okay, we're gonna. That's okay. We'll change this to H.
Ali, lo de arriba es
We'll change this to H.
Ah, bueno. Okay, now I get it.
You just wanted me to change it.
No.
So f of x is the top one.
Let's go, man.
G of x was the bottom one. And then we just took the derivatives. And I figured we were good to just take them. And you guys all did well on that part. Okay, so then let's simplify.
Wait. X2 is the derivative of f of x.
X2? No, the derivative of f of x is 6x squared minus 6x.
But why my question is first f of x, and you put first g of x.
Doesn't matter. Order of multiplication doesn't matter. 3 times 2 is the same as 2 times 3.
Why do you write it like that?
Why not?
Yo por eso también
You know why I write it 2 different ways? Because I want you to know how to do it, no matter how it's thrown at you. I don't want you to learn cheap tricks that you memorize. Hey, boys in the back corner, you guys are going for a walk in about 5,
It's no low.
4.
It's not low, it's high.
Thank you.
It's high low. You wrote it high low.
Oh my gosh.
Eso era lo que yo estaba diciendo.
You know what? Whatever. Okay, let's multiply these together. 6x to the 4th minus 6x cubed. Now we're going to multiply the 2x in. So minus 4x cubed. Nope, 4x to the 4th. Plus 6x cubed minus 4x. All over x to the 4th. Then I'm going to combine like terms.
2x to the power 4.
X to the 4th and x to the 4th.
Let's go, man.
X cubed. So I'm going to get 2x to the 4th minus 4x over x to the 4th.
Mister, you know what you should
Which is the same as 2x to the 4th over x to the 4th minus 4x over x to the 4th, which is the same as 2 minus 4x to the negative 3.
What's that?
Same Z's. Right?
What?
What do you mean what?
2 minus 4 to the x to the negative 3.
What? 2x to the 4th over x to the 4th is 2. 4x over x to the 4th is 4x to the negative 3. Right? 1 minus 4? Negative 3.
Let's go, man.
Manuel, Matias. Shut your traps.
And Mister, you should do. I can tell you.
You should do I can't tell you.
Can I tell you before you shut me up?
Okay. Spit it out.
You should do the things that Andres in precalculus does. That if you do the practice exams, you can have extra points in your test.
No.
Yes. You should.
No.
It motivates people. Yes. That would make you not have to.
You mean passing doesn't motivate you? Oh my god, that's awful. You should go see a shrink. No, guys, I'm not giving you free marks for doing the work you should do to be good students. You're seniors.
You need to like if you do it by mistake, you get extra. If not,
All right, find the equation of the tangent line drawn to this graph now. Now, if you look at this one, can you turn that into a polynomial-like graph?
Yeah.
No. How are you going to make that look like a polynomial? No way. You can't do it. Okay, so instead, we're going to do some quotient rule.
if we cannot make it into a polynomial to make it,
Then you should do quotient rule.
and if we can make it into a polynomial, we
Do whichever way you want. All right, low, low, D high, minus high, D low, all over, low squared. Guess what? You're done.
What?
G prime of -2. Well, you're done finding it. Derivative, I should say.
Why is the derivative of x minus 3 1?
Because the 3 goes away and the x becomes 1. All right. So now let's plug it in. G prime of -2. So -2 plus 3 is 1 times 2 is 2. 2 times -2 is -4 minus 1. Ooh, -5 times 1. Still -5 times -1 plus 5. -2 plus 1 or plus 3 is 1. 1 squared is 1.
So it's
I have a question. Why can't you just plug it into the original equation? I know that's.
Because that would be the y value, not the derivative. Right? It wouldn't give me the slope of the tangent line. So now I know that my SOT is 7. So that's my SOT. Right? Now I need my pot. My pot's going to be -2, and then I plug it into here, so I get G of -2. And I'm going to be -4, -5 over 1, which is -5. So there's my pot. So then I get y plus 5 equals slope times x minus the x coordinate, which is x minus -2 or x plus 2. Feel good? You cannot listen and write?
I cannot listen, see, write, think.
You can't think?
No, I cannot.
I know. Pobrecita.
O sea,
I knew you were gonna say.
Matías, are you all right, buddy?
Maybe se put some
Para que son buenos.
Good. All right, can we keep going? Yep. Hang on, I can't hear, guys. I can't hear. What? So what I did is I plugged -2 into the original equation. 2 times -2 is -4, minus 1 is -5. Over -2 plus 3 is 1. So my G of -2 is -5. 2 times -2, -4 minus 1 is -5. Times -1 gives me plus 5. It's minus -5. All right. Let's use the quotient rule. If that, then that's the derivative. Are you all right?
You gave us the derivative.
I did.
Yeah.
And we're going to see if you guys can figure it out. Ready?
But
Manuel.
can you go slow, please?
Okay. Low D high, which is 2x plus 3, minus, because what's the derivative of the top? 2 comes down, 1 comes down, 2 goes away. Boys, stop. Okay?
But that is only f of x.
Yeah, exactly. That's just the top. Minus high x squared plus 3x plus 2 d low 2x all over low squared. All right, the bottom's ready. Top, not so much. Need to make that top look like -3. Let's see if we can do it. So, what's up? You know I got a name, right?
No.
Fine, I'm going to start calling you girl.
Why isn't it? Why isn't it x squared? But what? No.
You can call me Mr.
Call you boy.
What do you want to?
Sorry, man.
What
That was mean.
to be called?
What do I want to be called? My name.
What? Brad.
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 But Mr. You have like a single name or something.
Bradford.
Stratton.
And just a
Yeah, but don't call me that. I told you that last year.
What is your name?
It's weird if you call me Mr. Stratton. Because that's not my name.
But you have to call you Mr.
But what's my name? It's not Stratton.
Before saying Brad.
Mr. Bradford.
It's Stratton. Y'all pronounce it wrong all the time. And my dad's a teacher, so it reminds me of my dad.
Your dad's a teacher. Your mama is Mr. But
Yeah, Brad's fine. Mr. Brad, if you want to be like super polite.
It's
All right.
years you're not having teaching.
Amelia's going to walk us through it. Okay.
No, I think.
Okay.
2x plus 3
Perfect. 2x cubed
plus 3x squared
plus 3x squared
minus 2x
minus 2x.
minus 3
Look at this girl go. Next.
minus 2x cubed
Look at her go.
plus 6x squared
Close. Minus 6x squared.
minus 6x squared plus 4
Close. Minus.
minus 4
4.
x.
There you go. Right? Because we're distributing. The reason is I'm distributing the negative at the same time. Yeah, the ninja, whatever that means. I still don't understand. Oh, it's a cheap trick. That's why I don't know it.
Oh, it's not.
Boo, cheap tricks.
Mauricio calls that negative.
No es Mauricio.
It's Mauricio.
All right, anyways. Then look. Now I can take it a step further. X cubes. X squareds. X's. Put them all together.
so that
So those cancel.
yes.
That one becomes negative 3x squared. Whoa. Hang on, I think we did something wrong.
No, you're right. You're fine. You're right. No, Mr. Don't tell.
Okay. Negative 3x squared minus 6x minus 3 all over x minus 1 squared. Oh, I see. Ooh, we're going to have to do some fanciness.
Yes, que yo le
But I did something wrong.
Yeah, x squared minus 1. I can see what's going on
I
here.
did something wrong.
I can see it. No, I know what's going on.
What did I do?
You didn't do anything wrong. I can see what's happening. All right, so we got to make it look like this, which means, guys, for the College Board, they'll often give you questions like this where you're going to have to do a bunch of algebra. So we got to, we're done, but we haven't done it, made it look like this, which means that now we need to go and do some algebra. So what could I pull out of the top there? Negative 3. So I'd get x squared plus 2x plus 1. Now on the bottom, stay with me here. What is x squared minus 1?
What?
X squared x.
It's a difference of squares. So it would be x plus 1, x minus 1, but then that's squared. So you could kind of think of it as like x plus 1 squared, x minus 1 squared. Would you agree?
Yeah.
Be the same thing. So technically I could write it like this, if you prefer. But if two things are multiplied together and squared, we can just square them both, right? Okay, you did that in the pre-calc like one-day test.
Wait, mister, you're running to us.
I doubt it. I think you're just too busy.
X
Hold on. Exactly. Now I got to factor the top. Look at this girl go. She's onto it. She knows what's going down. Negative 3, and the top is x plus 1 squared. Isn't that amazing? What's going to happen? What's going to happen? Bam!
Mister, you're
Right? Because the top, look, guys, look right here. X squared plus 2x plus 1. Guys, listen. X squared plus 2x plus 1 is x plus 1 squared. Right? Because 1 plus 1 is 2, and 1 times 1 is 1. So it's x plus 1 squared. Perfect. On the bottom, we had x squared minus 1 squared. Well, that's the same as saying x plus 1 times x minus 1 squared. Because we factored the difference of squares. If I have two things multiplied and squared, I can just write them both squared individually. Okay? It's all pre-calc algebra for you guys here. All right, so then, at that point, I am done. Look at that. Negative 3 over x minus 1 all squared. Samesies. We did it. We did it and we love it.
No, we don't love it.
You like it.
And you don't.
Hey, Mister, exit.
All right.
Right exit.
Okay. Guys, similar to the product rule.
Yo me la encima del año.
Man, you guys are squirrely today.
A mí la encima del año.
Guys, listen up.
Pero no tengo.
I'll just wait. Oh, there's a valuable lesson to be learned when we introduce the quotient rule. In the box below, first factor and simplify this.
I already tried to
Amazing. What'd you get?
x plus 2 times x plus 1
Yeah, you did.
over x minus 1 times x plus 2.
Close. X plus 1.
X
Right? Because
plus
it's difference of
yeah,
squares.
No, I just read it wrong.
It's okay. It's all good. I believe you. All right, so we're going to cross those out. Then I get this. So f of x is that, which would mean that will make, it's still, like I still have to do quotient rule, but now it'll be way easier, right? So I can do f prime of x is going to be low
Wait.
d high, which is 1, minus high
No.
d low, which is 1,
D high.
all over x minus 1 squared. What's x minus x? 0. What's negative 1 minus 2? Negative 3. Would you all agree that that was way easier? And we should probably simplify. This is the reason that we often simplify. Okay, so if like algebraically simplifying something doesn't really simplify it, then usually that's when you don't have to bother.
Sir,
But if it makes things easier, you should do it. Yeah.
shouldn't you let in the denominator x squared minus 1? Or in the same x, doesn't matter.
No, it's completely different. X squared minus 1 is not the same as x minus 1 squared. Because x minus 1 squared is
It's not a difference of square. Yeah, sorry.
like,
Yes.
right? That's x squared minus 2x minus plus 1, which is totally different, right? All right, so let's keep going.
No. Go on. Is that?
What's the lesson to be learned?
Mister, I have a question. Mister, I have a question.
Always factor.
X minus 1
If
doesn't
you can. Okay, go ahead.
doesn't cancel with the x minus 1 in the top.
No, because it has to be part of everything in the top before you can cancel something in top and bottom. It has to be a common factor in the numerator. If it's not, if this is like if you do this, you broke the rules of math.
Why?
Because you can only do that if x minus 1 shows up everywhere in the top and it doesn't. It has to be a common factor.
Sir,
Yep.
the x in the denominator is not a square. Inside the parentheses, x squared also.
Ah, ok. Pero si tienes 1 sobre 2.
All right.
Mister, and why did you get a 3?
Because x minus x is 0. Negative 1 minus 2 is negative 3. All right, guys. Okay, Matthias. Better one. Go for a walk. No, seriously, go for a walk. Go for a walk. I got to start somewhere. There's too many of you talking all the time. Go for a walk. Go for a walk. Come back when you're done talking.
I was the one that was less talking of the table.
Okay, well, when I looked up, you were the one talking, so go for a walk.
Listen.
It's okay. Hold Manuel's hand. Take him with you.
I know, Mister, you like.
It'll be quieter for okay, listen,
I'll fight this one.
if I have to say anything into this table again, all 5 of you are going for a walk.
5.
Can you not count?
It's like
1,
a word.
2, 3, 4, 5. Okay, good. All right, so, guys, whenever you see tangent, you should probably be thinking, if you had paid attention back when you did trig, is this is sine over cosine, okay? So that means that now if I'm going to find f prime of theta, it's going to be low d high minus high d low. I literally just said it. All over cos.
We have
Theta
to put
squared.
theta after every.
Now there's an easier way to write that. So the only reason I know that like the derivative of tan theta is secant squared is because I've done it a lot. You shouldn't just try to memorize all those
Okay,
things.
but technically using the identities will also be correct.
It's not an identity. It's memorizing things.
I have
And
a
yes, if you want to memorize it all, you will get it, but you're going to run out of space to memorize everything.
Okay.
Unless you are like a prodigy.
I have a question.
So hang on, let's finish simplifying and then you can. Wait, wait.
Uh,
So negative sine times negative sine would be positive sine squared theta over cos squared theta.
The answer is just sine squared.
Nope. So cos squared plus sine squared is really, guys, remember, you cannot do this. Stop trying to do that. Go talk to your Algebra 1 teacher and tell them they failed you, because you cannot do that, okay?
But why not?
Well, go talk to them or find them.
Not in
She
that
left.
Well, that's why. That's why she left. Okay, because she taught you poorly. No, guys, you can't do it. Like, I don't know how to stress that to you, but I can't keep spending time on it. You can't do it,
Only
okay?
you can do it
Because
when
it's
like
added.
No, no,
parentheses.
you can't do it.
But why not?
Okay, yeah. Yes, if it's a common factor, you can do it, but it has to be a common factor.
If it's adding, no.
Yes. Okay. Cos squared plus sine squared.
Oh no.
Thank God the BC student knows what's going on.
Cos
1 over cos squared is really secant squared theta. So, literally all we're doing here is we're proving that that's what it is. Now, if you do this a bunch, you're going to memorize that that's what it is, right? But like, if we ask the BC student, not all of them remember it all the time. They sometimes have to look it up. Okay? Like you sometimes have to look it up because you don't remember. So that's okay.
Pero what do you have to do?
Why do you look it up?
Because you need to know what the derivative of tangent theta is. Let's do cotangent, which is really
Can I ask you that?
cosine over sine.
Can I ask you that question?
Oh yeah, go ahead.
Why do you square it in cos theta and not in parentheses?
Say that again.
Why do you square it in cos squared theta and not parentheses square over?
I just think it's an easier way to write it.
But that doesn't mean that you're not squaring it.
No, you could write this. Hey, back table. Remember what I said? All 5 of you go for a walk. Go for a walk. They didn't make the same deal with me. You did. But I'm trying to answer a question and I can't because you guys are talking. So seriously, go for a walk.
We're talking about the question.
Seriously, go for a walk. All 5 of you, go. Walk to the end of the hallway and back. These are the same thing, right? So I just like this because it's easier to write.
And if we put it
Boys, I have to put your academic responsibility and behavior grades in right after this class. You should probably go for a walk.
Square
And you don't know it.
must
Not if you go for a walk. You're not paying attention. That's the point.
cos squared plus sine squared.
Rewatch the video because you're going to have to, and you'll see that you weren't paying attention because you can hear yourselves over everyone
Cos
else.
squared plus
Okay.
sine squared is what?
Huh? Yes. It's an identity that you allegedly learned when you did geometry. So guys, if we write this as d theta, that just means take the derivative with respect to theta. It's just another way of writing it. I'm going to switch it up all the time so you can see different ways to do it. Don't worry about it. It's the same as like f prime theta. Now, if tangent was like secant squared, what do you think cotangent might be? Close. It is negative cosecant squared theta.
Why negative?
What?
Why negative? For the same reason that the derivative of cosine is negative sine.
See, those like yes.
If we work out the whole thing, you'll see why. Because with the way that the derivative of cosine is sine, the signs are going to have to flip, and you're going to have to pull out like a -1. So the top is not going to simplify to 1, but instead -1. Okay?
Mister, I didn't understand what you
We have to memorize.
Don't worry. No, you don't have to memorize them. I said you'll memorize them naturally by just doing it a lot.
Mister,
All right. We'll do one of these ones. Okay, what?
You did the first one. That's the first step.
No, that's it. That's the whole thing.
That's all the same.
Well, guys, look. What I said is that we could do it. We could write it all out the long way. I figured you didn't want to. So instead, I'm telling you the second one because they're very similar. And then I explained,
Just the same word.
but just listen. Then I explained the only difference is that the top here is going to simplify to be -1 rather than 1. And instead of it being over cos squared, it's going to be over sine squared, which is why it's cosecant.
I
Okay?
understand, yeah.
So same thing here. I'm only going to do one of them, and then we'll just like from that extrapolate what the other one should be. So let's do the first one. Okay, so this one is really 1 over cosine. Okay? All right. So that would mean that the derivative, d theta, is going to be low d high. Derivative of the top is, 0. Minus high d low all over low squared. This all goes away, right? Anything times 0 is gone. So here I've got negative, negative, so that's going to cancel out. So it's sine theta over, and I'm going to write it this way, cos theta times cos theta. Why would I write it that way? Well, what's sine over cosine? So this is really just tangent theta over cosine, or tangent theta times, what's 1 over cosine? So just tan theta, secant theta. Okay? Now the other one, if we flip them, because this one, cosecant is 1 over cosine, or 1 over sine, sorry. Anybody want to take a guess? What do you think?
What can you do?
Instead of tan theta, secant theta, what do you think it was? Instead of tan, it's going to be if they're flipped. Hang on. But if tan is flipped, what's it going to be? Cotangent. And just like before, it's going to switch to being negative. And what do you think the other part is? Cosecant, right? If this one was secant, it's probably going to be cosecant. That's what it is. Guys, again, you can derive it. There's nothing wrong with that. You can do exactly what we did. It's the exact same steps. Okay? Except that because it's 1 over sine, it's going to be slightly different. Right? And that's why it ends up being negative cotan, cosecant. I don't need to derive all 4 of them, but I want to show you how to derive them. But the process is the same, okay? Cotangent is 1 over tangent, so it's cosine over sine. Okay? Pedro?
Do we have to memorize these, or are we going to use them?
You will use them. They're on my wall when you're doing work. During like the College Board test, you can probably honestly find them in other questions if you really need to. But you'll likely memorize these by the end just because we'll do a lot.
What do you mean find this other question?
Like in another question, they might give you the derivative. Yeah. All right, find the derivative of each of the functions below by applying the quotient rule. So, f prime of x is going to be low d high minus high d low, which is 1. Daniel, do me a favor. Lock them out. They're clearly not ready to come back from their walk yet. Can hear them walking all the way down the hall. Did you lock it?
Yes.
Good. All right. So, over low squared, right? I mean, this is simple enough to simplify that you probably should. So this would be 2x squared minus 2x plus 4x, so plus 2x minus 4 minus x squared plus 2x all over x plus 2 squared. Can you let her in? That's my daughter. She can come in.
Bella.
Yeah, it's Bella.
Mister, why
Because we're just, as you call it, the ninja. All right. So then I'm going to simplify these, put together things that are like terms. So 2x squared minus x squared is x squared. 2x plus 2x is 4x minus 4 over x plus 2 squared. Amazing. Oh, you know what? Let's write it the other way, just for fun. D over
It
dx.
doesn't fit.
D over dx doesn't fit? Sorry.
That's vegetarian.
Are you gonna mad at me again? Okay, sorry.
Sorry.
All right, next one. P prime theta. Do you guys think you can do it on your own?
Maybe.
Okay, I'm not gonna call it out then. Actually, maybe I'll just pause the video and I'll let you try it for a second. So, when we do this one, it's gonna be low, theta squared, d high, cos theta, minus high, sine theta, d low,
Not two things.
2 theta, all over theta to the 4th. Now, technically speaking, I guess if you wanted to, you could cross out one of those thetas. right? Because there's a theta here, theta squared, and theta. So like you could simplify it as like theta cos theta minus 2 sine theta over theta cubed. But like, right?
Rewrite it or
No, it's like up to you. Like, because you could cross out one of those, right? Because the theta's everywhere. Right? Because basically what I'm saying is I could rewrite this as like theta,
And do you recommend that?
depends, cos theta minus 2 sine. Pretend there's a theta there.
I told
Over
you
there's a sign.
theta to the fourth. Yeah, but that's because I'm doing extra work.
I told you the spaces.
You know what, Amelia? I'm beginning to learn that I'll just never please you.
No, you will.
Oh, good. All right. Let's try the
We
next.
leave it like that.
Ah,
Yeah, you can leave it like this. Either one of those is fine.
I
That's
thought
that. That's that.
Amazing.
Well, I did multiply because I pulled out the common factor of theta, which is why I can cancel it.
And these are we could do the exact same.
These two? No. All right, let's do the next one.
But like, so we can just leave it like the first one.
Yeah.
Sebastian, you're all over there.
I think it's the last friend.
Oh, Bella, you can go check and see if your friend's here. Okay.
Bella.
H prime theta. Let's do it. Ready? Low. Yeah. Low. D high. Minus high. D low. Now careful here. Negative cos theta derivative would be negative sine theta, which is really just positive sine theta. Amazing.
Wondering.
1 minus cos theta.
1 minus cos theta derivative is sine theta.
Yep.
I didn't.
Again.
I'll get there. Hold on. Okay, so let's take a look at this. How can we do it? Oh, right. Okay, so let's see. What can we do? I can expand that. I don't know if that's going to help, though. So I think what we're going to do actually is just we're going to do some fanciness over here with some identities. So sine squared theta, right? That would be this. Do you guys agree this would be sine squared theta?
Yes.
And you would also know then that sine squared theta is the same as 1 minus cosine squared theta. Okay? And if I had that, I could,
That is not like the order. That
well, this is just the sine squared plus cos squared equals 1.
Oh, you can.
No, I think I can do something. I got something. I got an idea here. Because then I could go 1 minus cos theta times cos theta. And then I could expand this to be 1 minus cos theta, 1 plus cos theta. Are you seeing it yet, guys? All over 1 minus cos theta squared. What's the common factor? 1 minus cos theta. So let's write it the long way just in case you're not seeing it. Okay? I'm going to pull that out. I'd get cos theta minus,
How do you think of all of that?
oops, it should be 1.
Space is too little.
Is there go back to where you change sine squared
Nope.
theta to
it's so sassy.
Not right now. Maybe afterwards, okay?
Why do you have so many keys?
Okay, so that means I could cross out one of those. And then, guys, what's cos theta minus cos theta?
Does it get
Wait.
Let's
Cos theta minus cos theta.
Zero.
Oh my god, the whole thing is just negative 1 over 1 minus cos theta.
All that from us. Can you scroll up?
Amazing!
How's that amazing?
How is that not amazing?
Scroll up boring.
That was phenomenal.
I agree with Bella.
All right, so let's take a look at this next one. Now we've got to find f prime of x. Actually, you know what? Before we do that, let's change this. This is going to be awkward. So let's make it into a single fraction over a single fraction. Okay? So this is going to be 3x minus 1 over x all over x plus 5. Then from there, if you have a fraction divided by a fraction, you do your weird year thing, or I like to say exactly, keep, change, flip. And so then we get that, and so it would be, I feel like now I don't have room to write it anymore. I screwed myself. Go away. Okay, so now f of x is going to be 3x minus 1 over x squared plus 5x. Okay? So now from there we can take our derivative. So low d high, which is 3, minus high d low, which is 2x plus 5, all over x squared plus 5x all squared. And guys, honestly, like with that one, again, like we can do the simplification. I'm not going to do it on every single one because sometimes you're going to have to do it, sometimes you don't.
And when do you know?
Usually when you're going to have to do it is like a multiple choice question because the answers are not going to be there. Or like, remember we did the one up here
So if you leave it
where I gave you, just wait, so I gave you a very specific form of the derivative and you're going to have to make it match.
so if
Hey, guys, are you serious right now? Stop. For twos.
in an FRQ, if you leave it like that,
All right. So we're going to stop for twos.
so if you
Go
leave
take
it-
a walk. No, just kidding.
If you leave it like that, it's fine.
Yeah, so like sometimes it's going to be fine to leave it that way. Like it just, there's no hard rule. Like if you're really unsure, guys, always simplify if it's easy. The truth is, this is a pretty easy simplification, but we got 5 minutes and I want to get through the next question. Okay?
So normally we should simplify. It's best to simplify.
Yep. All right. So now we got one that's a little bit more interesting here. Below is a graph of the function f of x, and let r of x be cos x over fx. Okay? Is the graph of rx increasing, decreasing, or neither at x equals pi? Okay, so I didn't give you a graph of what you wanted, but I'm going to ask you about increasing, decreasing, etc. This is also why, if you remember on your assignment, I told you it's really important to tell me which function's doing what and because of which function's doing what, right? So you have to tell me like h prime is increasing because h of x is increasing because h prime is positive, things like that, right? You got to tell me both functions. So we're going to have to do that here. So first, let's start by finding r prime of x, okay? Because if I want to find increasing, decreasing, that means I got to find my critical points and do a sign analysis, right? So if we look here, r prime of x is going to be low d high. So I'm going to move the negative to the front. Minus high d low, because if we put negatives in the middle, remember I've said like somebody always thinks it's subtraction, so it's better to put the negative out front. All over f of x squared. Okay. Now, we want to know if it's increasing, decreasing at pi. So really, that means we just need to know the sign at pi, right? So let's find r prime of pi. If it's positive, what does that mean the original function's doing? And if it's negative, exactly. Okay, so r prime of pi is going to be negative. Let's write it up. Should we write it up?
Yes.
Yeah, I think so. Negative f of pi times sine of pi minus cosine of pi times f prime of pi all over f of pi squared. Now, the truth is, we don't care about the number, right? Because we just need to know positive, negative. So the fact that it's at pi and you're a little freaked out, you're like, f of pi, I can't find that. Where is that on my graph? Like, it's 3.1415. Don't worry about it. You just need to know the sign, right? So first of all, let's do the trig ones because that's going to simplify some things for us. What's sine of pi? 0. So this whole part goes away. We don't care about it, right? So then I've just got negative of cosine of pi. So negative, what's cosine pi? And then f prime of pi. So look at pi. F prime means derivative. So slope, what's the slope of that line? Negative. And then does it matter what this is if it's squared?
Wait, mister, how did you know it was that line?
Because I'm looking at f prime of pi. So at pi, it's right here, and then the line. So negative times negative times negative is really negative over positive, which is negative. Therefore, r of x is decreasing at x equals pi because r prime of pi is, less than 0. Okay? Make sense?
Mister,
Yeah.
you canceled the indexing because it was positive 1.
All right, so then our last one here, we're going to be doing table question. As I've mentioned, we love table questions. They make sure that we actually know what we're doing. And so when we look at this one, we're going to estimate the value of g prime at 2.5. So you should immediately be thinking, okay, that's a secant line. Right, so then we're going to look at between the two closest points, so 2 and 3. And we're going to be looking for g. So that means I'm going to be doing g of 3 minus g of 2 all over 3 minus 2. G of 3 is negative 3. G of 2 is negative 1. So minus negative 1 is plus 1 over 1, which is going to just be negative 2. So if we want, we can write that out as like g prime of 2.5 is approximately negative 2. All right, what about if p of x is g of x over f of x? What is the value of p prime of 4? What does this value say about the graph of p of x when x equals 4? Give a reason. So first thing we're going to do is figure out what the actual derivative is. So p prime of x is going to be low d high minus high d low all over low squared. Then now that we've done that, we can find p prime of 4 by plugging those in. So f of 4, if we look over here, is 1. G prime of 4 is negative 2. G of 4 is 7. And f prime of 4 is 8. And f of 4, we had already said was 1, so 1 squared on the bottom. Then if we put all that together, 1 times negative 2 is negative 2. 7 times 8 is 56, so negative 2 minus 56 is going to be negative 58 over 1, so just negative 58. What does that say about p of x at that point? Well, since it's negative, that means that we can say p of x is decreasing at x equals 4 because we know that p prime of x is negative. Awesome. All right, so then let's look at this last example. No, we got 2 examples, sorry. Last 2 examples here. So here we've got, if you can tell, we've got a product rule mixed with a quotient rule, right? And so you might think, okay, well, what order do I do these in? I do them in the order that they kind of appear, just sort of like when you're doing multiplication and division in regular BEDMAS or PEMDAS, whichever one you guys are familiar with. So when I find q prime of x, the first thing I have is 2 things multiplied. So I'm going to apply the product rule. So that means I'm going to take the derivative of the first, so that's 4x, times the second, which is just f of x over g of x. Then I'm going to add to that, and this is where now I'm going to end up having to do a quotient rule. So 2x squared, the first one, times the derivative of the second, and that's where now I have to break into a quotient rule. So I'm going to do a nice big bracket here, and I'm going to do the quotient rule. So low d high minus high d low all over low squared. All right, now that I've got that big long derivative there, and maybe actually just to kind of make sure we're understanding. So this f of x here, the derivative of it is all here, right? And that's in the second part of the product rule. Whereas the first one, right, the derivative is right there. And that's why then f of x over g of x, the second function, it stayed the same in that first part because it's product rule. Okay, so now let's find q prime of 2. So this first part is just 4 times 2, so that's 8. And then we got to find f of 2 over g of 2. So let's go look up what f and g are. So f of 2 is 2, g of 2 is negative 1. So f of 2 was 2, g of 2 was negative 1. Plus 2 squared is 4 times 2 is 8, so that's 8 again. And now we're going to have to do this big part here. So g of 2 we just did, it was negative 1. F prime of 2 is 9. F of 2 we just did as well, that was 2. G prime of 2 is negative 1. And then g of 2 was negative 1, and then we're going to square that. So then we can continue to just work that out. So 8 times 2 is 16, over 1 is negative 16. Plus 8, let's work out what's inside here. So this is negative 9. 2 times negative 1 is negative 2. Minus that is positive. So negative 9 plus 2 is going to be negative 7 over 1. So just negative 7. Which means I'm going to get negative 16 minus 56, which is going to be 72. So Q prime of, sorry, negative 72. Q prime of 2 is going to be negative 72. All right. Last one here is we're going to need to find a composite function, the derivative of it, and then find the equation of the line. So that, of course, means we're looking for pot and sot. So let's just over here real quick. Let's find the pot. So it's 3 and v of 3. So I just plug in 3 here. So that's going to be 9 over, and I need g of 3. G of 3 is negative 3. So that's going to be 9 over negative 3 is going to be negative 3. And then to find my sot, I need to find the derivative first. So v prime of x is going to be, this is a quotient rule, so low, d high, which is just 3, because 3x, the derivative is 3, minus high, so 3x, times the derivative, low, d low, g prime of x, all over g of x squared. So that means that then if I'm finding v prime of 3, g of 3 we just did, it was negative 3, times 3, minus 3 times 3 is 9. G prime of 3, I don't remember. G prime of 3 is 6. And this is all over g of 3, which we had just figured out was negative 3 squared. So that's going to be negative 9. 9 times 6 is going to be negative 54. Negative 3 squared is going to be 9. Which means I'm going to get negative 63 over 9, which is just negative 7. So my sot's negative 7. So my line is going to be y plus 3 equals the slope times x minus 3. And so that would be my equation of the tangent line at x equals 3 to v of x. That's going to be it, guys. Then you can do the practice problems.